systems of linear equations. So that's what you had yesterday. You did substitution, you did graphing, you did elimination, but those were just 2 by 2s. So today we're going to talk about 3 by 3s and Gaussian elimination. That's just a fancy name that goes together with elimination, triangular form. So let me first make sure we understand what linear means. So on number 4 we have x squared plus y squared plus z squared equals 4. And then ask you, is this a linear system or not? There's other equations that go with it, but the point is, it's not linear because these have 2's. They all have to be 1's for it to be linear, to be straight lines. And we're not just talking about the xy plane, we're talking about 3 dimensions, x, y, and z. So 2 lines may not be parallel and still not intersect. For instance, the xy axis is like the floor. If we have a line that's running on the floor this way, and the YZ axis is up here, and you have a line that's running this way, they aren't parallel, nor do they touch each other. Okay, so there's infinitely many that are no solutions. There's lots and lots and lots. Okay, so let's talk about what it is we're looking for. So number 8 looks like this: x plus y minus 3z equals 8. Y minus 3z equals 5, and z equals -1. Alright, so these equations, this system is linear. They're all 1's. And what I'm going to assign to you, they'll all be linear equations. But the question is, what is it that we're looking for? This is the end result of what it is we're trying to do. We're trying to get z by itself, with no x and no y down here. Okay, and this is called a triangular form. That's what you want. We're going to eliminate the x value in the second row, eliminate the x value in the third row, and eliminate the y value in the third row. So we got to eliminate those 3 positions in order for this to be in triangular form. Once you have triangular form, you can solve it. Because z is -1. We're looking for the coordinates where those 3 lines intersect. So half of your assignment, you're going to have solutions. Half of them will be no solution or infinitely many. And we'll talk about those here in a minute. So once you know z, you can plug this into the z in the next equation. So y minus 3 times z equals 5. Everybody solve that? Everybody get that? Okay. Now that you know y and z, you plug those into the top equation, x plus y plus, minus 3 times z equals 8. Everybody solve that. Let's see what you get.
So is the z always given, or did you just solve it?
No. The next one you will have to find it. This is just the beginning. What do you do once you put it in triangular form? Good job. Alright, so this was a problem where it was already in triangular form. So how do we get a system into triangular form? That's the big question. So we're going to do number 18. This is going to take the rest of the board here. X minus y plus z equals 0. Y plus 2z equals -2. X plus y minus z equals 2. Okay, let y'all write that down. And we'll talk about what we're doing. When you had elimination in section 1, 2 equations and 2 unknowns, what did you do? What was it that you were doing in each of those systems to eliminate something? How did you do elimination? What'd you do? Subtracted. Canceled variables. How did we get those to cancel? Yeah, multiply equations by different numbers so you get opposite coefficients, like 5 and negative 5, 1 and negative 1. You can subtract if you want. The book teaches you to subtract. I don't ever subtract, I always add. If you're good at the subtraction, go ahead and do it. But I always add, so I don't care how you do it, just get the right answer. So here, step 1, what do you have to do? Step 1, you get rid of the x in the second row. On this problem, it's already gone. Step 1 is already done. Step 2, you get rid of the x in the third row. How do I eliminate that x? What would you do? What equations would you add together, and how to get that x to be gone? Okay? Or, we're going to add. That's fine. You go ahead and do that. I'm going to take a negative 1 times row 1 and add it to row 3. This means I'm changing row 3. Row 1 and row 2 stay the same. X minus y plus z equals 0. Y plus 2z equals negative 2. So what do I get in row 3 when I do this? Negative 1 times x is negative what? Negative x. Negative x plus x is 0. You just eliminated the x. But you have to multiply that whole row by negative 1, not just the first piece that you want. So negative 1 times negative y is positive y. Positive 1y plus positive 1y is 2y. Negative z plus negative z is negative 2z. Negative 1 times 0 is 0. 0 plus 2 is 2. You just finished step 2. What's step 3? Eliminate this y variable in the third row. Good job. So, I'm going to use this equation, because if I use the top one and I do something to it to add to the third equation, I'm going to get x back involved. Okay, I don't want to do that. So I'm just going to use these two. So what do I want to do to eliminate 2y? Yeah, multiply row 2 by negative 2 and add it to row 3. This is what I'm changing. So the first two rows stay the same. So I do the operation. Negative 2 times y is negative 2y. Negative 2y plus 2y is 0. The y's go away. Negative 2 times 2 is negative 4. Negative 4 and negative 2 is negative 6z. Negative 2 times negative 2 is positive 4. Positive 4 plus 2 is 6. There is your triangle. That's Gaussian elimination for the most part. So what is z? Negative 1. How did you do that? Okay. Eventually what we're going to do in this chapter is we're going to get these to be all 1s, and everything else is going to be 0s. We're going to eliminate everything other than that diagonal. And we do it all like this. Okay? So when we go to solve this, it's going to be the same thing as what we're doing as if we're getting rid of everything else. So z is negative 1. Everybody find y and then x, please. Just like what we did over here. We got 0 for y. Excellent. Who finished?
I have a question.
Here's 28. Let's see if you guys can start and get this going. The key here is put the variables in the right columns. And there's nothing that says you can't put this first row and replace it with the third row and flip them. You can rearrange these rows any way you want. If you think it would be better if you put this positive 1x on the top, this row, then switch them. Say that you're switching them. That's okay. I wouldn't do that on this one, but it's okay. You can change the order of that stuff. You're still going to get the same answer. All right. What is step 1?
Eliminate x in row 2.
Eliminate x in row 2. Okay. Do that, please. Let's see if we can do that.
So, this is negative row 1. You didn't change the signs in the first row. For that clear.
Because you're only adding the row to the other one to get a result. It doesn't change that first one.
Okay.
It's like when you were doing the elimination in section 1, you actually changed everything
Yeah.
and worked through it. This, we're not doing it that way. Yep.
I have a question.
Just row 1. So, row 2. You're changing that there because that's row 2. Yeah. Alright, I'll go ahead and start. See how far you get. So I'm going to take row 1 plus row 2. That means row 1 stays the same. We're changing row 2 by adding them together. We want the result of adding row 1 and row 2 together. This plus that is 0. 2 plus 0 is 2. 5 plus negative 2 is 3. And 4 plus 0 is 4. Now, I didn't write row 3 up here yet because we can still change row 3 at this stage. You can do more than one change at a time. So go ahead and do step 2. What's step 2?
Through y. Third.
Not yet. You gotta get rid of something else first.
Oh, the x in the bottom row.
You gotta get rid of the x in the third row. So I'm still looking at this system, I go, how do I get rid of this? If I take 4 times row 1 plus row 3, those will eliminate, won't they? 4 times negative 1 is negative 4, plus 4 is 0. So the x's go away. 4 times 2 is 8, 8 plus negative 2 is 6y. 20 plus negative 11 is 9. 16 plus 2 is 18.
Oh,
Slow down. What's the question?
Me?
Yeah.
Where'd you get the 4?
This 4,
Yeah.
pulled it out of the air.
you have to get rid of the 4.
You have to get, yes, this is a positive 4. Only way to get rid of a positive 4 is by adding a negative 4 to it. And since I'm adding equations, this is the best equation to use. Take 4 times this row, that'll give me negative 4, won't it?
Yeah.
So then negative 4 times plus 4 is 0. But you gotta take 4 times the whole thing.
And then we add that row to the third row?
Yep. And that gives me the new third row total.
Okay.
Alright, we're gonna do another one. Now, what's the third step?
Get rid of the y.
Get rid of the y in the
Third.
third row. Well, I'm not going to use the first row anymore because if I use the first row, that will introduce an x back into any of those rows. So I'm only going to use the second and third rows, which is what you did yesterday. You get 2 equations and 2 unknowns there. So I want to eliminate that 6y. What do we do? Do it. Do it. What?
I got like 0 on the side. 0 cancel.
You did it. You got a 0? Is that possible?
Yeah.
Are you, it is?
I don't know.
You sure you did it right?
It's a good zero.
No,
Yeah, it just means that there's no solution.
What did you do? Let's see if I can figure out what you did wrong. Or you don't think you did anything wrong?
Me?
Yeah.
No, I thought she was just asking what it meant if you got a zero.
Oh. Well, what, did you get a 0?
Yes.
You didn't do it? What are you doing?
What
What did you get? Alright, you tell me what you did.
I multiplied the row 2 by -30.
So, negative 3 times row 2 plus row 3. Alright, so row 1 stays the same. Row 2 stays the same. And we're changing row 3. So negative 3 times this is negative 6 plus 6 is 0. The y's go away. Negative 3 times 3 is negative 9 plus positive 9. The z's go away, leaving the 0 on the left. Negative 3 times 4 is negative 12. Negative 12, and you have to do this. Don't stop there. Negative 12 plus 18 is 6. Does 0 equal 6?
No.
So this is an example of no solution. Yay!
This is pretty much just what we were doing before, but with a third.
That's right! Ding, 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 ding. We have a winner. 1 out of 60 is a fact. You should be. Making rat noises. Okay, everybody.
Dang.
X minus 2y plus z equals 3. 2x minus 5y plus 6z equals 7. 2x minus 3y minus 2z equals 5. Solve that, please. Step 1, step 2, step 3. One step at a time. Let's go. It's the last one. Let's see if we can do it.
Let's see here.
Step 1.
Let's get rid of this.
Please stop.
Remember, you don't have to get rid of that first x first if you don't want.
We don't?
You don't have to, no. You just need to eliminate those positions. Alright? I just do them in that order just
You
because
lost
it's.
me there.
Alright, never mind. Just do them in that order. I do it in that order just to make sure there's a consistency to it.
Sounds good.
steps in one. Eliminated step 1, eliminated step 2. You don't see how I got it? Ask me. Time and look at it. This right here or this whole row?
That one.
I took -2 times row 1 and added to row 3. So -2 and 2 is 0. So the x's are eliminated. Yes?
Yeah. Why didn't you just do -1 times the second one?
Because I changed it up here. I could have done that first. I could have done that first. There's nothing wrong with that. Okay?
I'm lost. I'm out.
Hmm?
I'm lost.
You see why we multiplied by -2 here?
Are you supposed to get rid of the 2 in this? I mean the x in the second row?
Right.
Yeah.
So how do I get rid of that? I multiplied this by -2 to add these two together.
That's what I did, but I multiplied -2 times that whole second row.
No. It's times only the first row.
Only the first row.
-2 times row 1
Okay.
plus row 2. So -2, -2 times each of these.
Yeah.
Plus this. So -2 times -2 is +4.
Yeah.
Plus a -5 is -y.
Okay.
-2 plus 6 is 4. -2 plus times 3 is -6. -6 plus 7 is
Okay.
1.
So you
Okay?
only multiply the first row and then add to the next row.
Yes. If you need to do a different row, then you do that. It's just that's how these are being worked out. I'm just showing you a consistent method that will work. You may choose, like, you may say, look at this and go, well, I don't want to multiply that by anything. I'm just going to take -1 times row 2 and add it to row 3.
Would that still give you your new second
You,
row?
whatever, as long as you follow the rules, you will get the exact same answer as everybody else.
Yeah, they got something wrong. I don't know if can you come with us real quick?
Mhm. Okay, then get rid of that y on the third row, please. Where's,
Right here.
so you got rid of those two. Okay, so now you're doing this part. So you added these two together, so
Yeah.
that goes away.
Yeah.
That goes away. So that's a minus.
Yes, that's my solution. So isn't this solution?
I didn't say that.
Wait,
What?
Here we go.
I can't hear you.
So now I'm going to take row 2 plus row 3. Top row stays the same. Second row stays the same. Third row changes. The y's are eliminated.
Yeah.
The z's are eliminated. That's 0 on the left.
Yeah.
1 plus -1 is 0. Doesn't 0 equal 0?
Yes. Always.
Infinitely many. And that'd be wonderful if you were done at that point.
But we're not?
Not when it says infinitely
How's that
many.
even?
Remember the last two chapters where we did parametric equations? Parametric equations was really dealing with infinitely many possibilities. Anytime you have infinitely many, this is what you do. Ready? Whatever variable that was eliminated, in this case let z equal t. T is your parameter for all values of t here. What are we going to get? So right now what you're telling me is that in the z position, that's t. For all values of t. What can we get? So you got to come up with these parametric expressions to solve this. So just like you solved these things over on the first example, we're going to let t be z. So we're going to substitute t in for z here. So we have -y plus 4 times t equals 1. Everybody solve for positive y, please. So algebra 1, get y by itself. Positive y.
What did you say, solve for?
Positive y. So positive y equals
4t minus 1.
4t minus 1. Hey, guess what you get to do now?
Or the first equation.
Yep, put all those in the first equation. Solve, please. Tell me what you get. We'll see if you're right.
First equation. X minus 2.
Yep. Don't forget to distribute the negative 2 through the y. Your substitution. Remember, put parentheses around your substitution.
Do we need to put T in here, or we just put Z?
Yeah, t is z.
Okay.
That's what you do on all of them.
Okay.
When whatever z is.
Definitely. Awkward. So you dropped a T. But yeah.
Might just drop the T.
They said 9.5. Well, why would you do that?
Done? Haley, what'd you get?
I did, I have no idea what I'm doing.
Oh my gosh.
I think I got it.
I thought I knew what I was doing.
Did you substitute back in?
I was confused because I thought you wanted to put in the X, but you don't, and I don't.
Yeah,
X
solve for
position.
x. You already found z, and then you found y.
Yeah,
So to find x, you gotta substitute these in for the y and the z positions in the first equation.
yeah.
Okay, so we do that, we distributed, this is x minus 7t plus 2. And then subtracted 2, we get x minus 7t equal 1. Add the 7t, we get 7t plus 1. You got that right? Hey, alright, so when you have infinitely many, you gotta get the parametric expressions. Your assignments. Page,
Yesterday,
yeah, what I gave you yesterday, 17 to 37 odds. Anybody get this done?
Me.
right? Wait, 1737.
I thought that was due today, so I could.
Good. No, that's tonight's assignment.